Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I'm going to discuss about the wave optics, and this is the part one video. So I will go for the basics of the wave optics. Okay. So before that, speed of light, we know that speed of the light depends upon the nature. Speed of the light depends upon the nature of the medium. So Huygen supposed the existence of the hypothetical medium called luminous ether, which is fulfilled the entire space. This medium was supposed to be a massless and extremely high elasticity and low density. So basically Huygen has assumed that space is also filled with luminiferous ether, okay, which is very much elastic. Okay, now let us understand that, suppose there is a see, suppose there is a lake, right? There is a lake there is a lake, okay. So this is a lake, and a lake, and a boy is sitting here, and if he just throw a stone, so what will happen, it it will create a disturbance, and you will find that this disturbance will be like this. So basically, what is this? So this is a type of, so this circle can be considered as a wave front. Okay, so how this wave front has been created. Now let us suppose any wave is there, right? Any wave like this. See, let us suppose this is a wave, and it is moving like this, right? Moving like this, like this, like this. Now the topmost will be considered as a crest, and the lower part can be considered as trough, right? This is upper part is your crest, and up lower part is your crest. Okay. Now what will happen? You know that if this is a point source, and it will create a wave in each and every direction, like this, like this, like this. Now each and every wave has a crest and trough, crest and trough. If each and every wave has a crest and trough, each and every wave has a crest and trough like this, like this, like this, like this, like this, like this, like this. Now when you take a common tangent to each and every either crest or either trough, so you will find a circular shape. So this is known as wavefront. This is known as wavefront. Okay. So for a point source, you will find that for a point source, wavefront will be circular. Wavefront will be circular like this. Wavefront will be circular like this, right? These are the wavefront. Okay. If it is a point source, if it is your point source. Now, if it is a linear source like tube light, take a example of tube light, which is a linear source. It is a linear source, right? So, if it is a linear source, then what will happen? How it will create a it will create a wavefront? See here. Since it is a point source, every point source will create a circle like this, circle like this, circle like this, circle like this, like this, like this, like this. So this when you take a tangent on this, so you will get a cylindrical wavefront. Cylindrical wavefront. The front part of the wave. Suppose wave is coming in front of you. So the front part of the wave is known as wavefront. Now if the source somewhere the wave may be like this, like this. So it is diverging. diverging source wavefront. See, it will be diverging wave source front, source wavefront, right? But in some cases, you may find that there may be a converging source wavefront, right? And one more important thing is that the ray of light is perpendicular to the wavefront. So a ray of light, if you talk about the ray of light, so you will find a perpendicular. See here, these are the ray of light. So it is perpendicular to the wavefront. Everywhere you will find perpendicular to the wavefront, like this. A ray of light will be perpendicular to the wavefront like this. Okay, so it will be perpendicular to the wavefront like this. So it will be perpendicular to the wavefront like this. So I hope you have understood these type of things. Okay, now if the light source is infinite, see, if light source is infinite, so we know that whenever any infinite light source, light is coming from any infinite distance, so it will, what will happen, so light will be considered as a parallel beam of light only. And then what type of wavefront will be created? So wavefront will be created like this. See here, wavefront will be created like a plane. So this is a wavefront. This is your wavefront, and the light source is always perpendicular to the wavefront. So this will be the wavefront. This will be the wavefront. This will be the wavefront, right? So this is the wavefront. So I hope you have understood. So let us read here an important thing. It is a, see, what is a wavefront? It is the locus of the point, that is wavelet, having the same phase, a surface of a constant phase oscillation, and the wavelet is the point of disturbance due to the propagation of the light. And the line perpendicular to the wavelength is called ray. Depending upon the shape of the source of a light, wavefront can be of three types. So wavefront can also be considered as of three types. So we have already discussed this all three types. That is point source wavefronts, that is circular one, cylindrical one, and this one, right? So I hope you have understood this. So we have already done the spherical wavefront. So this is the spherical wavefront. So this is the spherical wavefront. This is also is spherical wavefront. Now this is the primary wavefront, and this is your secondary wavefront. Why this happens? See here. Let us try to understand that. Let us suppose this is a point source. First of all, I will clear and try to make you understand that. Let us consider this is a point source. This is a point source, right? What will happen? It will create a wavefront like this. Uh, it will create a wavefront like this. Got it? Now each and every point source will act as a, each and every point on this wavefront will act as a point source, and again this point source will create a circular wave like this. Got it? Wavelets. So these circular things is known as wavelet. This circular is section is known as wavelet. Now again, if you take a common tangent on this, so what you will get? Again, you will get a wavefront. So this is basically known as wavefront, and this is basically known as wavelet. Wavelet, right? I hope you have understood this. Got it? Now, cylindrical wavefront. So if light source is like this, so you will get a cylindrical wavefront. So see here, you will get a cylindrical wavefront like this. You will get cylindrical wavefront like this. You will get a cylindrical wavefront like this. Got it? When you connect it, so you will get a cylindrical wavefront, and the light is perpendicular to this. Light is perpendicular to this. See, everywhere you will find a light which is perpendicular to this. Light is perpendicular to this. Light is perpendicular to this. Light is perpendicular to this. Okay? Light is perpendicular to this. Okay? Now plane wavefront, when we will tell that the wavefronts are a plane, so let us consider a lights are coming from infinite distance, so it will create a perpendicular plane wavefront. Okay, so these are the plane wavefront. Okay, I hope you have understood this. So these are the plane wavefront. These are the plane wavefront, right? Wavefront. These are the plane wavefront, right? These are the plane wavefront. Okay, so plane wavefront. Got it? Now we will discuss that what is Huygen principle. Huygen's principle. It is essentially a geometrical construction which gives the shape of the wavefront at any time and allows us to determine the shape of the wavefront at a later time. So according to Huygen principle, each point of the given wavefront is called primary wavefront. So let us consider this is the point source and it creates a circular wavefront. So each point on this wavefront is considered as a primary wavefront. Primary source, primary wavefront, right? Primary wavefront is the source of secondary disturbance. So definitely this each and every point on this wavefront will create a secondary disturbance. What are the secondary disturbance? So these are the secondary disturbance which will be created by this. Okay, so these are the secondary disturbance, right? And when you take again a common tangent to this, so you will again get the secondary wavefront. Got it? And the wavelets emanating from these points spread out in all direction with the speed of the wave. So wavelet emanating from these points spreads out in all the direction with the speed of wave that is equal to speed of light. Got it? Now next is your a surface touching this secondary wavelets tangentially in the forward direction at any instant gives the new wavefront at an instant. This is called the secondary wavefront. See here, this is the point source. This will create a wavefront like this, and each and every point in the gain is creating a disturbance, and this disturbance when you take it, so it will create a again next wavefront. So likewise you will able to understand that how wavefront is being created. Now refraction and reflection. A reflection of a plane waves using a Huygens principle. So before that, we should discuss about the behavior of the prism lens and a mirror toward the plane wavefront. So let us discuss about behavior behavior of prism lens and mirror toward plane wavefront toward plane wavefront front, right? Now let us consider there is a prism and plane wavefront means what? See, we have already discussed that plane wavefront means a light is coming from infinity and it will create a plane wavefront. Okay. So first of all, plane wavefront. So I will use just only top view. So let us consider a plane wavefront is coming like this. So first plane wavefront is coming like this, second plane wavefront is coming like this, third plane wavefront is coming like this, right? Now these are the plane wavefront. Now let us consider this is your A and this is a B, okay, and it will each and every part will create a disturbance like this, you know that disturbance like this, right? So this will create a disturbance like this, got it? Now what will happen, again it will create a secondary tertiary wavefront like this and it will go beyond this, okay, but as soon as it will go beyond this like this, see here, every time it will go beyond like this. So as we know that this lower part will have to travel more in the prism. It means that speed will be less and upper part have to travel less in the prism. So what will happen, its speed will be high. So the time at which B reaches at this point, that is B dash, so at the same time A will reach at this position, that is A dash. So finally you will get a new wavefront and this will be like this, got it? So this will again be like this, like this, like this. So in this way it will move up, okay. So these are the behavior of the wavefront. And as we know that light is perpendicular to the wavefront, so let us draw the light, okay. So can we draw the light? So let us draw the light. So let us consider the light rays is perpendicular to this, like this. So what will happen, it will pass, see, light will pass like this. So this is what it is practically, you can see here. So I hope you have understood this, how to how to draw this type of things. So let us go for converging. See, let us go for a lens. So let us take a convex lens. Now if there is a convex lens, now let us suppose this is your convex lens, okay. And now we will take a rays wavefront for the light rays. So these are the light rays, these are the light rays like this, okay. Now let us consider this is A, this is B, this is C, right? This is A, this is B, and this is C, got it? Now what will happen, if light is coming? So see here, what will happen, it will create some of the disturbance. So let us consider this is creating a disturbance like this, disturbance like this, disturbance like this, like this, like this. This is also creating a disturbance like this, like this, like this, like this, like this. This is also creating a disturbance like this, like this, like this, like this, like this. See, the moment B reaches B dash, at the same time A has traveled in air more, so its speed is more, so A will go beyond that line. At the same time C is also go beyond that line, because the connection or the passage of the light or passage of the wavefront through the lens is very for a very less time, so definitely it will go ahead of this, okay. So see here, when we put a C dash as a point, B A dash as a point, so can we connect this? So when you will able to connect this like this, see here, connect like this, see. So you have to take a tangent, and if you will take a tangent like this, so it will connect like this. So now the wavefront shape of the wavefront will be like this. Shape of wavefront will be like this, like this, right? Like this. So it is more complicated. It will definitely appear to be more complicated, but to understand this, you have to be draw like this only. So see here. So this is a principal axis now. Now tell me, a light rays definitely is coming. A light rays A light rays is coming like this. See here. A light rays is coming perpendicular to the plane of the wavefront. So what will happen? See here. It will converge like this. Why converge? Because it is also perpendicular to the wavefront. So it is also perpendicular to the wavefront. It is also perpendicular to the wavefront. It is also perpendicular to the wavefront, right? So this is known as converging wavefront, right? I hope you have understood this. Now let us go for again next type of lens that is known as concave lens. So we can do experiment for any shape, right? So concave lens. So when you will take a concave lens, so what you should do, see here, this is your concave lens like this, right? This is your concave lens. And now again you take a light rays. So you can take a light rays in the form of a wavefront. So light rays coming parallelly. So it means that you have to take a light rays in the form of wavefront. So these are the wavefront. These are the wavefront. These are the wavefront. These are the wavefront. These are the wavefront like this. Okay. So these are the wavefront. So let us consider this is your A. This is your sorry. So this is your A. This is your B, and this is your C. Now when it will create a disturbance like this, so it will also create a disturbance like this. So the moment at which this A as well as C will reach at this point, so at the same time B has to travel less in the lens, but it has to travel more in the air. So definitely it will move ahead of this, due to which you will get B dash at this position. Now if you create more wavefront, so you have to connect like this. See here, you have to connect like this. See, like this. So what will happen again? It will create like this, will create like this, like this, like this, like this, like this. Got it? So you have to now take a light rays perpendicular to the wavefront. So let us consider this is light rays perpendicular to the wavefront. So what will happen? So it should be like this because this is perpendicularly. It should be like this. So it should be straight line like this. So it means that it is your diverging source wavefront. Got it? Now let us consider concave mirror. Okay. Now let us talk about the concave mirror. So as soon as we will draw the concave mirror like this. So this is your concave mirror. This is a concave mirror. There is a principal axis like this. There is a principal axis. Okay. Now what will happen? What will happen? A plane wavefront. So let us consider a wavefront, a plane wavefront. See, this is a plane wavefront is there, and it's your A, it's your B, and let us consider this is your C. Now it will create a disturbance, but in the backside. Why? Because it won't pass, because this is a mirror. So definitely it will create a backside like this. At the same time, it is creating a disturbance in this direction, right? Like this. But at the same time, it will create a disturbance like this and up, right? So if you connect all the tangents, so if you connect all the tangents like this, so what you will get, see here, you will get tangent like this. See, it will be a little bit like this. See here, we have to take tangent over final source. At the same time, we have to take a tangent like this. Got it? We have to take a tangent like this. So finally, if you draw the light rays to this perpendicular to this, so what you will get? See, you will get a light like this. So this is converging. So it is a converging spherical wavefront. So I hope you have understood this converging spherical wavefront, right? So I hope we have discussed all. So in next class, I will next part I will discuss about the refraction as well as reflection through the wave. Thank you for attending our class.